So this is your lecture number 6. We have finished adding and deleting to the linked list in the beginning, at the end, and at any other intermediate location specified, or by deleting any element that is mentioned, as in the value of the data of the linked list node. So what we are going to do today is your print, count, and search. So let's go to print first. How do you print a linked list? If you remember, I did 2 loops for traversing a linked list. The first loop had this while condition, while temp to next is not equal to null. This condition makes you stop at the last node. So if we are using loop number 1 to do the printing, how do we go about? It's the same loop. So we initialize temp pointer, we copy the value of start in temp pointer, then we start our loop. Our exit condition is if the next field is null, which means that the next field of our last node is going to be null. So when we exit this loop, our temp will have the value or the address of the last node. Okay, so we'll get to that in the end. So when we enter this loop, right now temp points to the first location. We are printing the data of that first location. Okay, then we increment temp to point to the second node. So it will go on, check if the second node is the last node or not. If not, it will come inside and print the value, the data for the second node. Then it increments temp again and makes it point to the third node. So if you remember the example that we took, it has 3 nodes. So now temp has the value 3000, and if you go into this 3000 to next is null. So that means we have hit the end of the linked list. So it will exit the loop. But if you notice, we have just printed the first 2 elements. We have not printed the element that is in 3000. So that's why when you use this loop condition, when you exit the loop, if you are printing or if you have to use all the values of the linked list, you have to add another printf at the end of your loop. That is, after exiting the loop, you are going to print what is in 3000 to data. Okay, so if you are using this first type of printf in a loop, you have to put in additional printf statement. So your first type is when you use this condition, temp to next is not equal to null, and in this condition you need to put an additional printf at the end. And if you use the second type of loop, so the second type of loop uses this condition, temp is not equal to null. Okay, temp is equal to start, so you put the value of start in temp, then you use this as the exit condition. So till temp is null, it will keep on printing. So it will print your 5, 10, 15, and then temp turns to null and it will exit. In this case, it printed 5 and 10 inside the loop, but it printed 15 outside the loop with reference to the linked list that we are using. Okay. Another thing that you have to take care of before using this kind of a loop. In this loop, you are always checking whether your linked list is empty or not, because you are using the condition if temp is not equal to null. If start was null, if there was nothing in the linked list, this condition would exit and then you would proceed with your code. But in this case, we are not doing that check. In case, let's say your start was null, there's nothing in the linked list. So if there's nothing in the linked list, then null to next will give you an error. So it's always better to put a check at the beginning to see whether your temp is null or not. In case it is null, you have to skip all of this and you'll not get any error. It's like an error check, like we do when we enter, when we ask the user to enter some value for a program. Let's say we say, user, please enter numbers from 1 to 10. So if the user enters 11, we will display an error because we don't have a choice for 11. So similarly, whenever you do something like this, you always put a check before this to see if your temp is null or not. Okay, so this is your printing a linked list. Next, what we have to do is count the number of elements in a linked list. So again, we are going to use the same loop. The traversal loop for linked list is same. What we need to modify is what we are doing inside the loop. Okay, so again, we can implement this counting elements in two ways based on the two types of loop that we have created for traversal. The loops differ with respect to their conditions, this condition. So what we do, we first initialize count equal to 0 because we are going to count the elements. Initially our count variable is 0. We initialize temp to start. We check. This is what I did not do in the printing before, so you should always do this just in case your linked list is empty. So if your temp is null, then you return the count, which will be 0. If it is not null, we increment count. So I'll tell you why we do this. You can do it here or you can do it here. Just like this. If you remember in the print we just did, when we are using this loop condition, we are printing the elements here and the last element we are printing outside the loop. So similarly, when we are counting, we will be counting the two elements within this loop because of this loop condition, and we will exit the loop when we are on the last node. So to count that, we have to add a count plus plus here. So you, in this kind of loop, you can either do it at the beginning or you can put this count plus plus at the end after you exit the loop. So what are we doing in this loop? While temp to next is not equal to null, just like we printed, instead of printing we are incrementing. So in case of print, we printed the first data element, and in this case we are incrementing count to count plus 1. Then we are moving on to the next node. You're checking if the next field of this node is null. If it is not null, we go inside, again do an increment, again move on or jump to the next node, go back. If the next field is null, that means we have stopped at the last node, so we will come out and do count plus plus. In case you have done it here, then this is not required, this or this. Okay, so you can put plus plus count before, or you can just move the statement here. Okay, so this will be your counting the number of elements in a linked list. So it's very important to understand how this loop works, because you are going to use it everywhere. When you have to add at the end, delete at the end, even if you have to find or add or delete at a position, or search an element, or count or print, everywhere you're using this loop. So you can use it in two ways, either this or let's say this loop 2. So this is again with this loop condition, temp is not equal to null. So temp is start. While temp is not equal to null, I do count plus plus and then I move to the next node. See, I have not had a check of temp before because this will take care of that. I did not do it if temp is equal to null. I did not do a pre-increment of count or a post-increment after the loop. I just, because this condition will take care of, it will traverse through the entire linked list. Okay, and then we do count plus plus, move on to the next one, check if it's null or not. If it's not null, we do an increment again, and we move on to the next node. So let's say if you're doing count here, when you're here, temp is first pointing to the first node, your count is 0, you enter the loop because next field is not null or this is not null, you do plus 1, you go here, again temp is not null, you do another plus 1, so it becomes 2, you go here, it's not null, the count becomes 3, after this temp changes to null and you exit. So you count correctly the number of nodes in the linked list. So similarly, now that we know how to use these loops either this way or this way, this is helping us traverse or move or get to any node in the linked list, but in a sequential order. So we are going from start. You cannot jump to the 6th node straight away. That is not how linked list works. You have to go from 1, 2, 3, 4, 5 and then you'll get to the 6th node. So sequential access, it is a problem in the sense that you have direct access in arrays, but when you think of insertions and deletions, just a couple of pointer changes and you can modify the linked list anywhere at any spot. The only problem is that you have to use this loop, which is kind of additional work, but it has its own benefits. Okay. So now searching in a linked list. So again, to do anything with a linked list, we need the same traversal loop, and within the loop we see what we have to do. For example, traversal in the loop means you're going from one node to another. You want to search something in the node, you want to modify a particular node, you want to add before or delete. So you can get to any node and do whatever you want to do. So when you have to search, we're essentially searching for an element, if it's present in the linked list or not. So if it's present, I'll return a positive answer. So what I do is I initialize my temp pointer to start. Found is a variable which I am setting to 0. If at the end of my loop found is still 0, that means my element is not present in the linked list. So I'm using loop number 1 while temp to next is not equal to null. Just like you print data, instead of printing, what I'm doing, I'm checking the data against element that I'm searching. So this will be passed to me in the function through the main function. Okay, search for this element. The element value is stored in ELE. I check if temp to data is equal to element. If that is the case, I change found to 1 and then I proceed to the next node. So maybe element is not present in the first node, then I will move on to the next node. So again, notice here, let's say I'm looking for node, I'm looking for the element 15. Okay, so in this kind of loop, it will exit while when temp is pointing to 15. So you'll never get to check if 3000 to data is equal to 15. So you will have to add a similar statement at the end, just like we added an additional printf, just like we added an additional count plus plus at the end of the loop. You will have to do it here in case you are using loop type 1. Okay, so you have to do it here. Again, you have to check before entering if temp is null or not, so that you don't encounter an error. So simpler in this case is to use this loop, because this will go through the entire linked list without you having to worry to put any condition after the while loop. So if temp to data is element, found is 1, and then you loop. So you continue doing it till temp hits null. So you will, when this is 3000, you are still inside the loop. This will change to null here, and then when it changes to null, you exit. So you don't have to put any additional condition at the end. Now that you know how to print, how to search, how to count, you can also find the element that you've been asked if an element is present or not. You can say yes or no based on the found at the end of your loop. You can also add another counter within this loop for finding the position of this element. So you can have position. If you remember, we did add and delete at a particular position. So we had a position counter which we were incrementing. So if you are finding if you're looking for an element in the linked list, you add another condition here that you also save the position of this element, and then you can have both the position and the fact that the element is present. So because you know how to find a position, how to get to a position, you should also be able to modify this loop so that you can say yes, the element is present and it is present at this location. So I'll leave that as an exercise for you to do. So find if an element is present and also give me the location of that element. Okay, so you'll do that as an exercise in the end. So this basically covers pretty much everything basic that you can do with linked list. There's a lot more we can do with linked list, but if you know these 5 things properly, add, delete, print, count, and search, you are pretty much okay with the linked list, but make sure that you understand this well and you are able to implement it on your own. So the linked list programming link that I have mentioned in the lecture outlines, please go through that. You will see that these same snippets of code that I have given to explain each function, they will be present there as a proper function. There will be a main program which will help you do multiple things provided in the menu, and you'll see all of these being implemented in a similar fashion. Maybe they've used different pointer names and different structure type, but you should go through that after you understand these properly. I'll be sending these note screenshots as well, hopefully by the end of the day today. Okay, thank you.